All right, today we're just going to talk about different ways of measuring angles, and one is degrees, minutes, and seconds. So minutes and seconds are fractions of a degree, and radians is a new way of measuring rotation. So if we had something like this, 30 degrees, 15 minutes, 30 seconds. Each minute, 1 minute is 1/60th of a degree. So we could say that 1 degree equals 60 minutes. And then we could say that 1 minute equals 60 seconds. So if there are 60 seconds for every minute, we could go 60 times 60, and then we would have 1 degree is equal to 3,600 seconds. And so here are how they're related, and now we can just convert. So if we have 30 degrees, then we would do plus 15 minutes. We want to cancel the minutes and replace it with seconds. If we're converting all of this into a decimal, then we would want to go 15 minutes times the conversion of 1 degree to 60 minutes. And then we could have 30 seconds converting to degrees, 3,600 seconds. 1 degree is 3,600 seconds. And we have the minutes canceling. We'll be left with degrees. So we have degrees plus degrees plus degrees because the seconds cancel also. And we're just going to go 15 times 1 over 60. 30 times 1 over 3,600. If we do that on the calculator, we'll get 30.2583, and the 83 repeats, and that'll be degrees. Okay, so that's degrees, minutes, and seconds. We can convert between a decimal to degrees, minutes, and seconds, or we can go degrees, minutes, and seconds back to a decimal. And then afterwards we'll introduce radians. All right, so we have a degree, and we're going to break it up into 213 plus 0.875 degrees. We want to convert this into minutes. So we're going to multiply by the conversion factor. 60 minutes is 1 degree. So now degrees will cancel, and we multiply that. So now we have 213 plus 52.5 minutes. When we multiply this on the calculator, 0.875 times 60, we get 52.5, and the degrees canceled, so we're left with minutes. These are minutes. We don't want a decimal minute, so we're going to then write it like this: 213 degrees plus 52 minutes plus 0.5 minutes, and then we'll convert minutes into seconds. And 1 minute is 60 seconds. So then we have to multiply 0.5 times 60, and we'll have 213 degrees plus 52 minutes plus 30 seconds. And we would write it as 213 degrees, 52 minutes, 30 seconds. All right, pause and try the next one. So we multiply 0.314 times 60, and that's 18.84. Take the decimal, we'll convert the decimal, but we'll leave the 18 there. When we multiply 84 times 60, 0.84 times 60, we get 50.4, and we're going to write 67 degrees, 18 minutes, 50.4 seconds, and we'll just round the 50.4 to 50. All right, and pause, try the next one. So here, when we multiply 0.015 times 60, we get 0.9 minutes. So we're not going to have any minutes. We'll just convert that into seconds. So we don't have seconds. We don't have minutes. We just have seconds. All right, and we'll just convert each of these to degrees. We have 89 degrees plus 56 minutes. We need to convert minutes into seconds. We know we want to cancel seconds and be left with degrees. So now we just have to figure out what's the conversion factor. In 1 degree, we have 60 minutes. And so now we're going to be dividing by 60. Here we have 7 seconds. So we know we want to have seconds cancel, and we want to be left with the degree. So we know that 1 degree is 3,600 seconds. And then we just divide here, and add it all up, and we get 89.9353 degrees. All right, pause and try the other one. So here we want to cancel minutes. We'll put that in the denominator, and we want to be left with degrees. Here we want to cancel seconds, and we want to be left with degrees. So we have 1 degree is 60 minutes, and 1 degree is 3,600 seconds. If we do that on the calculator, we have 31.709 degrees. All right. So that's converting between degrees and degrees, minutes, and seconds. Now let's talk about radians. And radians are, a radian is defined as the arc length around a circle divided by the radius. And we often use S for arc length and R for radius. All right. Then we just want to think of how can we understand this a little bit better. If we have the circumference of the circle is 2 pi r, then that tells us that the number of radians, if we start here and we go all the way around the circle, we know the distance traveled is 2 pi r. And if we want to know how many radians we rotated, we would take the arc length and divide by the radius. So we have 2 pi. And once we know this, then we can find out all the other angles within a circle, because we know that going around a circle is 2 pi radians. So if you rotate 360 degrees, you get 2 pi radians. What happens if we go halfway around a circle? So here's the same circle, but we're going to only go right there. So that must be the angle rotated is pi radians. So this angle is 2 pi radians. And we know that 180 degrees is pi radians. So now let's look at what if we only go 90 degrees, we rotate 90 degrees, so the angle is half of that. If this is pi, then we've gone half of that rotation, so now it's half of pi, pi over 2 radians. So remember that a radian is not a length. We started out with a length, but then we divided by radius, so now it's just a rotation. So the circumference is a length, the distance around a circle, but if you divide by radius, now we just have this measure of rotation that's independent of the size of the circle. All right, then we have to know where all the other angles are. And so let's look at, first let's review the angles in degrees. 0 degrees, 180 degrees, half of that is 90 degrees, half of 90 is 45 degrees. And if we know that each of these angles is 45, we go 45 plus 45 plus 45. So 90 plus 45 is 135 plus 45. We're going to add another 45, add another 45, add another 45, add another 45, and we'll be at 360. We can do the same thing with radians to know where angles are located in radian measure. And it's even easier with radians because we have 0 and pi. Now, each one of these is 1/4 of pi. 1, 2, 3, 4 angles. Pi divided into 4 angles. So each one is pi over 4. And now we just add that as we go around. Pi over 4 plus pi over 4 is pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. Or we could just count 1, 2, 3, 3 pi over 4. 1, 2, 3, 4, 4 pi over 4. 1, 2, 3, 4, 5, 5 pi over 4. 6 pi over 4. 7 pi over 4. So until you memorize the location of all the angles, you just can draw this picture and count around. So here let's try to draw 30-degree angles, multiples of 30. And we have in degrees 0 degrees and 180 degrees. 1, 2, 3, 4, 5, 6 equal angles. 180 divided by 6, so each angle is 30. And now we can just add 30 to 30 and we get 60, plus 30, plus 30, plus 30, plus 30, plus 30. And then we'll go back to 360. And we can do the same with radians. So we have 0 and pi. We have divided pi into 6 equal parts, so each part is pi over 6 radians. And then we can just count our way around. 2 pi over 6, 3 pi over 6, 6 over 6, and then some of these can be reduced. So this is equal to pi over 3, and this is 2 pi over 3. Here we have 4 pi over 3. Here we have pi over 2, 3 pi over 2, and then this will be 5 pi over 3. All right, so 45 degrees. And we should start recognizing whether these are multiples of 45 or multiples of 30. So 45, if we are dealing with a multiple of 45, just be aware of these are the possibilities, and we're going to go to 45. So we can see without doing a real conversion, we just see, oh, that's, if this is pi, then that'll be pi over 4, and we've already converted it. But here's also, if it's not a special angle, we have 45 degrees. We want to cancel degrees and be left with radians. So the degrees will cancel. We want to be left with radians, and then we need to know the conversion here. So we know that pi radians is 180 degrees. And when we multiply that, we get pi over 4 radians. Okay, and then we have the possibility of a negative rotation. And since we're dealing with a multiple of 30, let's draw all the 30s, and we can just count where the negative 60 would be. This is, if this is a positive rotation, this is a negative rotation. There's 30, and that'll be 60. We know where that is. We could convert it just from the picture, and that would be pi over 6, negative pi over 6, negative 2 pi over 6, or negative pi over 3. You could already see that it's going to be negative pi over 3. But the conversion would go like this. Pi radians over 180 degrees. And then we reduce that. We get negative pi over 3 radians. Okay, pause and try the next two. And we have two tens, so if we count by 30, 30, 60, 90, 120, 150, 180, 210. So we're going to rotate all the way there. We can also convert right now 1, 2, 3, 4, 5, 6, 7. That's 7 pi over 6, and we're all done. We know the answer. Or we can multiply 210 pi radians over 180 degrees, and we end up with 7 pi over 6 radians. Okay, 135 is a multiple of 45, so let's draw 45s. And we're going to rotate negative 135, so that's going to be negative 45, negative 90, negative 135, rotating to there. And we can count pi over 4, so that's going to be negative pi over 4, negative pi over 2, negative 3 pi over 4. So we already know the answer is going to be negative 3 pi over 4. And we reduce that, we get negative 3 pi over 4 radians. Okay, we'll stop there for today.